an estimated 2 billion people worldwide live in areas that lack proper solid waste management systems. Inadequate waste systems present serious risks to human health and the environment. The United States Environmental Protection Agency's Best Practices Guide for Solid Waste Management and accompanying learning modules present best practices for solid waste management in developing countries. This video builds on the separation, collection, and transportation section of the Best Practices Guide to provide more detail on how to optimize collection of solid waste. Collection costs make up a large portion of a city's waste management budget. These costs can be reduced when cities consider more efficient ways to collect and transport waste, including route optimization. Cities must consider several factors for waste collection, including what types of wastes are collected, how is waste collected, specifically, how will source separation be carried out and what type of bins or receptacles will be used to collect the waste, how frequently should waste be collected, what collection routes are best, what type of vehicle should collect waste, how will collection changes be communicated to the public, when vehicles break down or when bad weather prevents collection. What is the best way to communicate when waste will not be collected due to factors like bad weather or a broken vehicle? Cities must work with stakeholders to identify the problems that can bring collection to a standstill. With these factors in mind, cities can explore ways to optimize collection routes to improve service and efficiency. Benefits of route optimization include reduced labor, fuel, and vehicle maintenance costs. Additionally, fewer miles traveled results in fewer vehicle emissions and reduced fuel consumption, which benefit human health and the environment. Improper collection routing can result in high collection costs, increased emissions for local communities, and in inefficiencies such as less than full loads. This is particularly common in developing countries where municipal authorities may not be able to implement proper or uniform systems for waste collection and transport. These problems will only intensify with increased urbanization in developing countries. Cities can optimize collection routes using these 4 steps. First, cities should review their existing policies to understand who is responsible for solid waste collection of each waste stream. Consider how waste collection is financed, the labor laws affecting the waste collectors, and the service area. The second step is macro routing or assigning daily collection routes. It is important to look at all existing collection, transfer, and disposal sites throughout this activity. To do so, determine the optimum amount of waste that can be processed and disposed of each day. Then, divide the collection area into subsections that collection crews can realistically service on a given day. The third step is route balancing and districting to ensure that the workload is distributed equally among collection crews. Using districts or subregions of waste collection optimizes waste collection, since districts are often grouped by businesses or households which have similar waste characteristics. With set districts, waste collectors better understand what type of vehicle they need, the fuel they need, the length of time they need, and the type of waste that will be collected in a given area. The city of Ibarra City, Ecuador proposed collecting waste by residential and commercial districts. Using mapping data and waste generation information, city's officials created an optimal distribution plan for waste collection crews in each district of the city. The fourth step for route optimization is micro-routing or reviewing a service area to determine collection vehicle routes. Micro-routing considers geographic features, demographics, one-way streets, road construction, vehicle design, point of collection features, requirements for residents and businesses to set out their waste on the street, and collection frequency. Cities should consider route adjustments based on seasonal changes or population growth. Cities can also consider special waste needs, for example, when there is a festival or other special events where waste will be generated in larger quantities. When developing micro-routes, cities can identify the appropriate vehicle types to match local conditions. The selection of waste collection vehicles can greatly impact the efficiency of a solid waste collection program. Common types of waste collection vehicles include hand carts, pedal carts, animal carts, motorized tricycles, tractor and trailer systems, trucks, and fore and aft tippers. The composition and quantity of waste will impact the collection vehicle selection. For smaller quantities of waste, a motorized tricycle could be most effective. For larger quantities of waste, cities may want to use larger trucks. When collecting separated waste types, such as organics or recyclables, cities may opt for vehicles with multiple compartments. The number of customers and frequency of stops impacts vehicle selection. Consider the collection roadways and space limitations as well. For example, the road width or narrow alleys could prevent the use of a larger vehicle. The road or pavement conditions and traffic patterns can impact collection efficiency if larger vehicles get stuck in traffic or on low-capacity roads. Considering vehicle maintenance can help cities save money by selecting vehicles that are commonly available, easy to maintain, or have spare parts readily available. Consider vehicles that can be fixed locally using parts that do not need to be imported. Performing routine maintenance helps operators understand how long a vehicle will run before failure and what parts may need to be replaced first. Certain vehicles can help cities reduce overall greenhouse gas emissions and meet a city's environmental goals. Low emissions or alternative fuel vehicles are an increasingly popular option to reduce waste collection's contribution to local air pollution and climate change. In Rio de Janeiro, Brazil, the city purchased 3 electric waste collection trucks to collect municipal waste from hospitals. The vehicles produce fewer greenhouse gas emissions and less noise compared to traditional collection trucks. The city estimates that the trucks have a lifetime 5 times higher than fossil fuel vehicles. When optimizing waste collection routes, some cities have incorporated smart systems with global positioning systems, commonly known as GPS. Before utilizing GPS, Ipoh City in Malaysia conducted a territorial analysis, which helped identify topography, road conditions, and other restrictions, such as narrow streets, to waste collection. During this portion of the study, Ipoh City noted the current routes of waste collection trucks, waste generation type of waste bins, and traffic information. A map was created using data from the territorial analysis, Google Earth, and local government departments. The city then implemented Geographic Information System, or GIS, technology to create a digital map of the waste collection areas. Ipoh City layered different information such as roads, drainage, elevation, topography, and building locations. Using the digital map and its related data, researchers and city officials implemented mathematical models, including an advanced connectivity model and a spatial analysis that examined routing, travel directions, and waste facility locations. The model generated the most efficient travel routes for trucks during solid waste collection, including speed and time spent in traffic. GIS information and existing models can be utilized in cities across the world to aid route optimization. In Trabzon City, Turkey, the city used handheld video cameras to analyze solid waste collection process. Video footage allowed city officials to view how each vehicle was collecting waste at each stop and how factors such as traffic affected the speed of collection. Waste collection vehicles were also equipped with handheld GPS receivers to track the distance that the truck moved. City officials calculated how each route could be shortened, considering vehicle type and waste generation rates. Inadequate solid waste collection presents serious risks to human health, the environment, and livelihoods in many cities. Utilizing these steps, cities around the world can begin route optimization to improve solid waste management. Visit Section 9 of EPA's Solid Waste Management Guide for more information on route optimization and vehicle selection. The guide is part of EPA's Solid Waste Management Toolkit. Scan this QR code for more information. Thanks for watching.